The topic now we are going to see is pipeline data path. What is mean by pipelining is multiple instructions are executed in an overlap manner. So in pipelining, each instruction is divided into 5 stages and they are executed. So the first stage is the IF, which is the instruction fetch stage. Second is the ID, which is the instruction decode or the read register file. Third is the EX, which is the execution stage. Fourth is the MEM, which is the memory access stage, and the last stage is the WB, which is the write back stage. So in pipelining concept, from fetching the instruction from the instruction memory until the data is written back into the register, the instructions are divided into 5 stages as we have seen. In the first stage, we have the instruction memory. Here we have two memories, separate memories, both for the instruction and the data. In the instruction memory, the instructions are stored. Instructions are set of command to perform certain operations, and in the data memory it stores the data, so operands. So in the first stage, instructions are fetched from the instruction memory. While an instruction is being executed, PC will increment its value by adding it with 4 using the help of an adder. So why the PC increments its value means, so the next we have to get the next instruction that is going to be executed. So here each instruction will be stored in the 4 bytes, that is 32 bits. So for example, for an first instruction is, for example, if an instruction is stored in the address at 100, so the second instruction will be stored at the address of 104. So the PC will increment its value by adding it with 4. Current PC value will be added with 4 to point to the next instruction to be executed. The second stage is instruction decode or the read register file. Here the instruction is decoded and the registers in the instruction will be read from the processor register, and in the third stage, execution or address calculation is done. For the arithmetic and logical instructions, arithmetic and logical operations are done, and for the load and store instructions, address calculation is done. And in the memory access stage, the data from the calculated address in the previous stage is accessed. The address calculated in the previous stage is used in this memory access stage, and the data from that address is accessed, and the data is sent to the next stage, which is data is written into the register at the write back stage. So these are the 5 stages and its uses. So pipeline registers. So for 5 stages we are having 4 pipeline registers. So pipeline register separates 2 stages and it is named. So which 2 stages separates the pipeline register is labeled for that pipeline registers. For example, the first pipeline register separates the instruction fetch stage and the instruction decode stage. So it is labeled as IF/ID. So on the second pipeline register separates the ID instruction decode stage and execution stage. So it is labeled as ID/EX. So likewise the other 2 registers also labeled. Pipeline registers, what is the purpose of pipeline registers is, so it gets the output from the previous stage and passes it to the next stage. So now we are going to see an example for the pipeline data path. Now we are going to see the load instruction. So in this load instruction, first the offset value 100 will be added to the value of the register S0, that is the address. So 100 plus S0, it will give some result. So that is the address. The address in the data in that address is accessed and stored in the register S1. So here in this load instruction 100 and S0 register, the data in that S0 register will be added, so it gives some results. So that result is the address. The data in that address is accessed and stored in the register, loaded in the register S1. So that is the load instruction. So in that instruction fetch first stage, so here the highlighted portions indicates that are all the areas where the operations are done. So the second half, so right half, if the right half is highlighted means, so that indicates the read operation is being done. If the left half is highlighted, that indicates the write operation is done. So right half, if the right half of something is highlighted means, that indicates that read operation is done. Left half indicates right half indicates the read operation. So in the instruction fetch stage, we are accessing the reading the instructions from the instruction memory. So reading is done in the right half, so the right half is highlighted. So here PC will increment its value using the help of the adder. So all these are highlighted. So after reading the data, it will write that reading the instruction, it will write that instruction in the register, pipeline register, first pipeline register. So writing is done. So left half is highlighted. So next stage is instruction decode and register file read. Here in the previous stage, the result is written into the register. So the written result is, we have to read that. So reading is done in the right half. So the right half is highlighted to indicate that the reading operation is done. So in that register we will read the data. So the right half is highlighted. And the sign extension is also done. So the sign extension also highlighted. So the result is written in the next pipeline register. So the left half is highlighted. So in the next stage, execute or address calculation. So in the previous stage we have written the output. So here we have to read that. So in the second pipeline register we are reading the data. So the right half is highlighted and the ALU calculation is, so ALU address calculation and the execution is done in the ALU unit. So which is the ALU unit is highlighted and the multiplexer is highlighted. So and it is written into the next pipeline register. So the pipeline register EX/MEM is highlighted at the left half to indicate that it is the data is written. And the last stage is the fourth stage is the memory access stage. So same wise here the data is read. So the right half is highlighted. So we are accessing the data, reading the data from the memory. So the right half is highlighted and the data read is written into the last final pipeline register, which is the MEM/write back register. So written into the last pipeline register. So the first half, left half is highlighted and the last stage is the write back register, which is the, here the data is read from the last pipeline register and written into the register. So writing is done in the left half of the register. So the left half is highlighted. So this is how the load instructions perform the operations through these 5 stages in a pipeline manner.